And we have Chaw Chit Su Thwe to talk about creating your own language in Python. And so give her a warm welcome.
So hello everyone, thank you for coming to my talk. Today I'm going to talk about what does it take to create a language of your own, especially a domain-specific language. So you can pronounce my name there, Chaw Chit Su Thwe, and I'm from Myanmar. I've been in Japan for like 2 years for now, and I'm right now working in Hangul. I don't know if you have seen this logo before. We have a sponsor booth up in the sponsor area, so please come visit us if you have time. So yeah, before we start with anything serious, we start with the quiz. It will be very easy. I'm just going to ask you some questions about if it's general purpose programming language or a domain-specific language. So you just need to raise your hand when I ask a question. The one example is in Hangul. We have this expression language called access condition expression, where we use in our admin control system, where admin can set a set of rules and it determines if a user be able to log into the system or not. For example, you can set IP addresses, or you could set, this is the login user is admin or not, or you could use operator. You could combine these expressions. So the question is, please raise your hand if you think this is a domain-specific language. Good job. Good job. It is a domain-specific language because it won't work outside of our Hangul system. Another one is emoji code. I don't know if you have heard of it. I just surfing through the internet and I found randomly. This is what they print. This is what print statement looks like. You basically printing, hey. And this is how they define dictionary. And then they loop through the dictionary and print the items. The question is, do you think this is domain-specific language? Please raise your hand if you think this is domain-specific language. Oh, okay. So yeah, this is, I would consider it's the general purpose programming language. Another example is HTML. So we all know what HTML syntax looks like, or not. So this is a paragraph. This is image. So please raise your hand if you think this is a domain-specific language. So this is considered as a domain-specific language because this is used in the web browser domains. So yeah, now we know what general-purpose programming language is. It's basically we could use across domain, and there's no specialty domains. You could use in any field. And domain-specific language basically is trying to solve a specific problem in a specific domain. So I want to talk about how how this talk came to be. So last year I attended a PyCon JP, and one of the keynote that kind of resonate with me. So the speaker talked about how most of the programming languages are in English, and how about people where English is a second language, for them it's very inaccessible, especially as someone from Myanmar. English is my second language, and people in the city, they do get a chance to learn English, but how about people from rural area? If they want to learn programming language, basically they have to know English first before they can learn programming language. So that's how it came to be. And I used to work in the organization where we taught programming to children. That was my background before. And when you teach children, basically storytelling is one of the strategy that you could use too. So everything combined, and this is what happened. We're gonna talk about it, how we're going to experiment with it, and how we could make a domain-specific language that we could use in a teaching fee as well. So now I have a purpose. I want to do something, but how do I make it? I'm gonna break it down into steps. The first step is knowing your domain. I know my domain. I'm going to write a story, but through code. But who are the user? I'm not going to make a general purpose programming language. I just want to make a really small one, easy for kids. That's my target audience. And so step 2, we go into actually know what type of domain-specific language we want to make. There were like 2 that you could consider, internal and external. Internal, basically like a library that you import in your Python. You install them and then you import them. Basically, they follow your Python syntax. For example, PyTest is also considered as a domain-specific since the domain itself is like a testing framework. And you still have to follow certain rules if you want to use a PyTest, like you have to define your function name, start with test, let's say. Or it can be click, it follow the PyCon decorator rules. So for the external DSL, it's completely derived from the host programming language. It has its own syntax, and you are going to make a parser and interpreter so that your syntax will be understood by the system. For example, SQL query language, basically you don't need to technically know the programming language to excel at the query language. You just need to be excel at this domain-specific language, or HTML, CSS. So I've decided I'm going to make a totally different syntax from Python. I want to make my own language. Step 3, we're going to design the syntax. This is where I spend most of my time and brainstorming. So I was like, OK, how about this? Basically, I was directly translating the Python syntax to Japanese. I was like, OK, that's a good start. But it's like, OK, but you just basically translating. There's nothing interesting about it. I was like, so when we learn a language, we learn how to make a sentence. So I was like, I will make a sentence. So for print, I'm going to like subject, verb, object. But I want to make it in Japanese. I was like, okay, that's my syntax, guy. That's what good enough. I'm gonna go with this. So I just say, "Neko ga hello to itta." And then, okay, like print is not enough. I want to declare. I know Python doesn't have like declare or anything. You can assign variable, but I'm gonna declare anyway. So we have neko. Neko is a character. We're gonna declare the neko is a character. Another syntax is we're gonna assign the value to the identifier. This is the best I can come up with for this. Basically, I just assigning hello value to greeting, and at the end, I just put obueteru. And another syntax that I came up with is if-else. This is just a basic Japanese syntax sentence that you make when you're learning JLPT and 5, probably. Moshi greeting nani 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 nani, sore nakereba nani nani nani. So yeah, I was like, okay, this is enough. I'm going to actually build a parser now. But parser basically composed of 2 components. So one is Luxor, where it's going to break down your sentences into like tokens. For example, in this syntax, we have neko ga hello to itta. And we're going to break it down into each tokens. Like I recognize neko as a character, and ga as a particle, and hello as a string, and to ita as like a say. Like we just kind of break it down into like tokens. And then after with that tokens information, we are going to make a parser that's going to analyze those tokens and then extract the relevant information out of it. For example, I don't need ga information, like ga particle or like period. So basically, I'm going to like drop some of the irrelevant information out of it and just say hello, say neko and hello. That's what I need. Or you could build like this. It can be any structure that you want, however your system going to understand it. It's fine, up to you. I'm gonna talk about some of the libraries that I found. One is lark, where to use lark, you basically define a grammar. Let's say this is hello, comma, word, and exclamation mark. This is how you define a grammar file in lark. And then you're gonna load that grammar into your parser. After that, you're gonna parse the input like this. And it's broken down, like it returns the tree structure. Another library is PLY, that's what I use in the end. You first define the tokens like this. And then you're gonna define regis rule. Word is basically just like a string A to Z. And we're gonna define the grammar, where we are going to define our grammar statements with word, comma, word, exclamation. Finally, we parse the input into our parser. And this is what the output looks like. We have statements and hello world. So we're using PLY mainly because I want to have more control over my parser and the parse information that I get. So for my print statement, this is the syntax again to remind you what my syntax looks like. And we're going to break down into tokens. We have neko, subject, and ga particle. We have string, and we have say, to ita, and we have period. After that, we're gonna define regis rules, where in the subject, I'm going to allow emojis, and we have other regis rule like ga particle or say and period. And we also have a string where I'm going to strip the bracket. So you could either define a simple regis, or you could define a function with a regis, so that you could make more operation under the function. So you could use like two ways in PLY. After that, you're going to define your grammars statements, where subject neko ga hello to ita and period. And then I'm going to extract the important information. Say is basically a keyword that will be important later on. And P1 is basically subject, and then this is the string information. And for the declare syntax, this is again reminding you of my syntax. The same thing happened. We're gonna break down the tokens, and then we define the grammar. But in here, I am going to make a custom attribute, which is called defined character, into my parser. And like I try to save the set of characters that I define into the set, so that in my print statement, I can kind of check this defined character and if it's already defined or not. If it's not, it's going to be return an error. So yeah, for the assign statement, again, this is the syntax. Do the same things again, tokens, and we define token regis. Now for the, this is to say it has its own grammar statement. And then I'm going to make another custom attributes where I'm going to save a key and values of these assigned variables, which we are going to use in if-else. Again, this is the syntax. Do the same thing again in tokens with tokens. And in the if-else, this is the if-else structure, grammar structure. So this is where we use the assigned variable. I'm trying to get the assigned variable's value, and then I will put it in my parse structure. As you can see in my if-else grammar statements, there's like I allow multiple line statements. I might want to print multiple code or lines. So I have to make sure that my program understands and how to parse the multiple statements. So this is what it does. What it does is that if it's see the two statements, it's going to like go through each line and then parse them and put it into the list. Another one, something we have to consider is compiler or interpreter. Compiler, basically, it translates the entire program into some other language or machine code. So for example, and then it's basically fail early. In C++, this is a print statement, and we have this 10 divided by 0, which is basically a 0 division error. But in here, it's going to crash early. It's not going to print anything at all. Your program going to crash. So the idea around is that when you have your domain-specific language, you're going to parse it, and then you're going to generate it into some other code. It can be Python, or it can be JSON, or anything that's understood by other program, and you execute it. Another way is interpreter. It's interpret and execute line code by code and during the runtime. Like Python, basically you print them, and if you have error, it's going to let you know that there is an error. It stays print hello world at first. So the idea around it is that when you have domain-specific language, you parse it. You don't need to generate it into other code. You just interpret them immediately. So I'm going to use the interpreter approach because I don't want to generate into the other general language code. So step 5, we go into actually with interpreter. Again, we're going to use my print statements. This is the syntax again. I think at this point you guys will be like expert as Japanese. So this is the tokens that we have. As I said, this first part is important because our interpreter going to match the first items of the tuple, and when it match, it know what kind of information that this parser is trying to give this, and it going to kind of like do what the interpreter is supposed to do, print them. And for the if-else, yes. And yeah, there's like a tokens not token. This is the parse information that we have. This is the if statement, and this is the this is the value that we assigned. This is the value that we're trying to compare. This is true statements, and this is the false statements. So basically, if I see the if keyword, I'm going to kind of like break down each tuple value into respective variable, and then compare them. And if it's true, I'm going to interpret the true statements, or otherwise it's false. So I also have like some error where if the character is undefined, you are going to see that this is the undefined character. So I have a keyword error. So if we see error, it's going to print the error. So yeah, so this is step set, but it's not actually a step set. Basically, this is something you consider when you are designing a syntax. This I added it last minute, so it became a step set for me. So basically, when you make a syntax, there are like some kind of keyword that you know that this is the end of the code, line of the code. For Java, it can be like this character, or block, or simply n. So at first, I was trying to recode line by line by recognizing a new line. For example, like I split my block of codes into line by line. I parse them line by line. I interpret them and then I output the result. But one thing is that my if structure is very long. So sometimes I want to like break down. So this method doesn't work in the end. Like I want to make sure that my program support the multiple line statements. And yeah, and also like my if-else statement, it already support multiple lines. So I just need to kind of update my program to make it understand. So I update my parser a little bit. So I make sure that I have a program keyword, and it understands that there are multiple statements. And if my interpreter see the program, keyword, it's going to interpret that it knows that there are multiple statements, and it's going to loop through that, interpret them like recursively. Yeah, and then so in here, I only need to parse it once, not like code line by line. I just need to parse it once and then I interpret them. So yeah, I have now everything combined. I have something that is walkable. I write the script, I run, and I will see the result. This is what it looks like. So I have a neko character declare up in the first line. And then I have neko ga hello to ita. So basically it prints that, oh, neko, hey, hello world. Yeah, like, what if I didn't declare? Then it's going to have an throw an error. After that, this is like all the syntax that I have wrote in my grammar. I have a character declare, and I print the hello world. And I have like assigned hello to my greeting variable. After that, I have greeting variable trying to compare with this string. And then I do the printing hello, or I will say bye. And this is what it does. Or if there are like some kind of code that you put and you haven't defined in your grammar, then it's just say, oh, syntax error. Now I have working example, and as a recap, first of all, you have to understand your domains, and after that you choose if you want your domain specific language to be internal or external, and design the syntax, base the parser, and base compiler or interpreter. So with this step, I think you can like make your own small domain-specific language in the end. And yeah, that's it. This is the end of my presentation, and thank you for coming to my talk. We are now searching for talents, and you can be part of it if you want to. So you can like scan the QR code and like join our challenge. Thank you.
Yes, thank you very much, Cici. And yeah, we have a couple of minutes left for questions. If you have a question, raise your hands.
Thank you for the talk. So while building this, your personal language, did you try using regular expression to identify things dynamically? Or you kept it like hard-coded everything? So I wanted to ask,
repeat the
yeah,
questions?
while trying to build this thing, the language of your own, did you try using regular expression to identify the tokens?
Yes. So this is the PLY feature. This is the parser library that I use. Basically, you have to define the registers for it to recognize, for the parser library to recognize your grammar.
Yeah, I am wondering if you tried it at your end while.
If I try what?
If you tried it while, creating this one.
Like make my own parser?
Yeah, exactly.
I didn't think about making my own parser at all. So, but I would say like the main idea around this is that if you were going to build your own parser, you're just trying to like, you tokenize them first, and then you try to like recognize your pattern. Basically you have more control over it. It doesn't have to be regis. Like as long as you're the parser that you are building, trying to like understand it, then you should be fine. It doesn't have to be regis.
Thank you.
Any other questions? In the back.
Well, first of all, thank you for that interesting thing. I just want to have a question that how can we have more elaborative error handling? I like that we are getting that invalid syntax, but in Python we get that track back and something. Like, let's say neck hoga, hello, that bracket is not present. So can we have more comprehensive error handling if we code. Is it possible?
You mean for the grammar syntax that I came up with?
Not just invalid syntax, like we have in Python trackback, int is not something, or tuple is not mutable, something like that.
Okay.
Can we achieve it?
Yes. Basically, in PLY, for me, I'm using tuple, which is difficult to understand. I understand it because I'm writing it. But basically, you could make your own data structure if you want to. It can be like dictionary, or you can even make a class if you want to. So you have control over this. Thank you.
Right, we have a few more minutes if anybody has more questions. Oh.
Thank you for the presentation. Super interesting. I'm just curious, after this exercise,
Yes.
Do you feel like you appreciate the Python syntax more? Like, how do you feel about it? Like, you know, like indents and stuff.
Yes. I mean, for me, I've been using Python like every day, so I got used to it. And also, like Python is like an easy language to start as a beginner, probably as well. I would say Python is simpler. And mine is really complicated. It's basically you're just making the whole new sentences. So basically, you have to write a lot of Japanese character to get to one point to another. So I won't say this is like should be used into like actual real world or anything, but it's just something that you could use to teach children, so that they got like and have an understanding of what programming is supposed to be.
Thank you for sharing.
Right. More questions? No? I have a question. Have you tried to just change the Python grammar to use your words? So you can like just reuse all of the rest of Python, but like have your own syntax?
I didn't try it,
You
but
can do that, by the way.
You could do it too, but I'm like, no, I want my own syntax. I want to be unique. Okay, like.
Nice. I love it.
Yes.
All right. Yes. Thank you so much, CC, for your great presentation.